Hello everyone, my name is Lewis. My topic for today is geosynthetics and pavement design. So before I start discussing geosynthetics and pavement design, first I want to define what geosynthetics are. So all of them are made from polymer products. They're typically durable polyethylene or polypropylene polymer, and they all serve slightly different functions, but they have a common purpose, which is lessening the impact of water on soil, along with increasing stabilization. So I said before, they all have different functions. For example, geotextiles are permeable fabrics that can separate, filter, protect, or drain when used with soil. Geonets are similar to geogrids, but they're placed in various angles to drain liquids or gases. Geocells, for example, are widely used to control erosion. They stabilize the soil on flat ground along with steep slopes, and they protect channels. So all of them have different functions to use out in the field, but they do have a similar goal. Some benefits of geosynthetics are that they can be buried underground, underwater, or built into walls. They can literally be installed anywhere. They have several functions. They separate soil, some reinforce, some filter, and some drain. Um, they are also very economical. Stated by the journal Functional and Cost Benefits of Geosynthetics, the subgrade reinforcement and the design of flexible pavement, they were found to reduce 6.38% in the cost of construction when they used GeoGrid as a subgrade reinforcement member, which will be discussed a little bit later on. So basically, they have really good performance at a cheaper price. The only disadvantage I could find is that they can cause failure if improperly designed or installed. So where is it used? I see on this list they can literally be used anywhere, from roads, airfields, to canals and dams, and all the way down to landfill liners. The picture on the left, for example, is geosynthetic in a landfill. This is probably going to be used to stabilize the slope or be a barrier to liquid so it doesn't go through into the soil. But basically, geosynthetics can be applied anywhere. So how are geosynthetics used in pavement design? As y'all can see, there are two different types of pavements, rigid and flexible pavement. This image also shows their layers. So as I said before, you can use different types of geosynthetics for different purposes, but the most common in pavement design are to separate the soils. Basically, they keep the soils separate in their own layers, which will increase the lifespan of the road. They can also be used to reinforce soil. It actually increases their tensile strength. It's very similar to adding steel and concrete. It can also act as a permeable layer where water will seep through down below. So geosynthetics, you can use different types. For example, you can use geogrids, which will actually reinforce the base and optimize the pavement, both on weak and stable subgrades. You can also promote aggregate interlock, which will increase the bearing capacity of the pavement and distribute the load force, which will create a more stable foundation. And it can also reduce surface cracking, which is a huge problem. It can lead to water infiltration and lower the quality of the road. So geosynthetics is pretty useful in the pavement industry. So as y'all can see in the image above, you can place geosynthetics basically in any part of the road and it will serve a different function. This isn't the only factor. You can also change what type of geosynthetic you're using. But basically, it can separate two different layers. It can reinforce a layer, stiffen a layer, filtrate, drain, or act as a barrier. For example, when it separates layers, the geosynthetic is placed between two different materials. It maintains the integrity and the functionality of the material, and it can provide long-term stress relief. So an example of this is reflective cracking. It can actually help prevent reflective cracking. So reflective cracking is when the original pavement cracks, and then it actually encourages the cracking to go upwards to the surface of the road. But when you add a geosynthetic layer, The cracking distributes along the layer, and it doesn't actually reach the new asphalt overlay, which is seen in the image below. So the left side shows how the cracking reached the new asphalt, and the one on the right shows where it stopped where the layer was put. So in conclusion, geosynthetics and pavement design is a pretty good method. It's actually pretty sustainable. You have to repair the road less, meaning less trucks come out to the field to repair it, reducing the carbon emissions. It also improves the roadway structure, and you reduce how many times you have to maintain it over its lifespan, and it increases its lifespan. So it also saves you a lot of money. And the need for durable roads is pretty important as traffic keeps increasing. So geosynthetics should be used a lot more often, and they're actually used pretty often, which is a really good method in this field. And this last slide is my references, and that is the end of my presentation. Thank you.